Hello everyone, welcome to Compiler Design video series. In our previous video, I have already discussed about what is LL1 grammar, how to check whether the given grammar is LL1 or not, how to compute first, how to compute follow, how you can parse the string, error recovery in predictive parsing. So all these topics are already discussed in our previous video. In this video, I will discuss about bottom-up parsing, shift-reduce parsing, operator precedence parsing, different terminologies like handle, handle pruning, viable prefix, then what is handle and what is handle pruning. Handle of a string is a substring of the string that matches the right side of a production and whose reduction to the non-terminal of the production is one step along the reverse of rightmost derivation. It means right hand side substring of a string is replaced by left hand side non-terminal. And what is handle pruning? The process of discovering a handle and reducing it to appropriate left hand side non-terminal is known as handle pruning. So this in example, write sentential form id1 plus id2 into id3. So in this string, first handle is id1. Your grammar will be E gives E plus E, E gives E star E, or E gives id. So your handle is id1 and reducing production is E gives id. So this id will be replaced by E. Next, second handle is id2 and again reducing production is E gives id. So id2 is replaced by E. Next handle is id3 and E gives id. So this id3 is replaced by E. Now next handle is E star E. E gives E star E. So this E star E is reduced by E. Next handle E plus E. E gives E plus E and this E plus E is replaced by E. So in bottom up parsing, reducing from input to starting symbol or root of the tree. And in bottom up parsing, derivation will be at rightmost derivation. In a shift reduce parsing, there are 4 basic operations will be performed, which is shift, reduce, accept and error. In a shift, it's moving of the symbols from input buffer onto the stack. This action is called shift. In reduce, if handle appears on the top of the stack, then reduction of it by appropriate rule is done. So this action is called reduce action. Accept, if stack contains start symbol only and input buffer is empty at the same time, then that action is called accept. Error, a situation in which parser cannot either shift or reduce the symbols, it cannot even perform accept action, then it is called error action. In a shift reduce parsing, there are 2 types of conflicts occurred. First is shift reduce conflict and second is reduce conflict. In a shift reduce conflict, situations like S gives small a small b. There is two production from S. S gives a b. And another is capital A gives small a, small b and small c. So your grammar statement like S gives AB and capital A gives ABC. At this type you have conflict. Either you can reduce or you may shift another input symbol like A and B. Whenever input A and B is passed at that time, either you can reduce it with S or it may be possible to shift C then reduce ABC to A. So it's a shift reduce conflict. And second one is a reduce conflict. For example, capital A gives small a and capital B gives small a. So whenever you have a small a at that time, it will be reduced by either A or B. So it's a reduce conflict. For example, shift reduce parsing. E gives E plus T or T. T gives T star F or F. F gives ID. And your input buffer or input string is ID plus ID into ID. Draw one table in which three columns. First is stack, second is input buffer and third one is action. Which action will be performed? First start with $sign in your stack, then your input string which is ID plus ID into ID, and at the string you have to put $sign. Now pass this input to the stack, then move either shift or reduce. If you can get your starting symbol, then this string will be accepted by this grammar. Here your starting symbol is E. So in a stack you can got E, and in an input string you can got only $sign. It means this string is accepted by this grammar. So first put $sign into stack, then after input buffer column put your string ID plus ID into ID, at the end put $sign. First operation is shift. Just shift first input symbol onto the stack. Here you can move ID on stack. So in input buffer remaining string will be plus ID star ID and $. Now this ID is reduced by F because F gives ID. So your action will be reduce F gives ID. So this ID will be reduced by F. Input string as it is plus ID into ID $. You have any relation from F to plus? No. You have any relation from T to plus? No. You have any relation from E to plus? Yes. So from F you can reach at E according to your grammar? Yes. Not directly, but F gives, T gives F and E gives T. So from F to T and T to E. So reduce T gives F. So F is reduced by T. Input plus ID into ID $. Now this T is reduced by E because E gives T. So this T is reduced by E plus ID into ID dollar. Now move this input symbol onto the stack. So operation is shift. So plus is shifted into stack. Next again ID is shifted onto stack. So here E plus ID and in input buffer it will be star ID and dollar. Now E plus ID. You have any production like E plus ID? No any direct production. But E gives E plus T, T gives F, F gives ID. So from ID you can find either F or T according to input symbol. So here reduce ID by F. F gives ID. So ID is reduced by F. You have any production like E gives E plus F? No. So F is also reduced by T. E plus T. Next shift. So move star to input symbol to stack. Next again shift ID. So your input becomes empty. Now this ID is reduced by F. You have any product T star F? Yes, T gives T star F. So reduce T gives T star F. Now E plus T. E plus T is reduced by E. Your input buffer is empty. In a stack you got your starting symbol. So string is accepted. So ID plus ID into ID, this string is accepted by grammar. E gives E plus T or T. T gives T star F or F. F gives ID. Next, operator precedence parsing. First, what is operator precedence grammar or what is operator grammar? A grammar in which there is no epsilon in right hand side of any production or no any adjacent non-terminal is called operator precedence grammar. If any grammar is given and then asked like this grammar is a operator precedence or not, then how can you check this grammar is a operator precedence grammar or not? Just check its right hand side production. In operator precedence grammar there is no any epsilon symbol and no any two adjacent non-terminal. It means E gives EE. This type of production is not possible in operator precedence grammar. In operator precedence parsing, we define three disjoint precedence relations: less than, greater than and equal between certain pair of terminals. A less than B. A is precedence to B. A equal B. A has the same precedence as B and A greater than B. A takes precedence over to B. It means A less than B, A equal B and A greater than B. For operator precedence grammar, you have to find leading and trailing of non-terminal. So what is the leading? How to find leading of non-terminal or trailing of non-terminal? So leading of a non-terminal is the first terminal or operator in production of that non-terminal, and trailing is one of the non-terminal is the last terminal or operator in production of that non-terminal. Leading it means first terminal or operator, while trailing it means last terminal or operator. For example, you have grammar E gives E plus E gives E star E, and E gives ID. So, first find leading and trailing of E. After finding the leading and trailing, you have to establish the relation between operators. How can you establish the relation between operator? If you have any terminal, non-terminal, terminal, terminal, non-terminal, terminal, then relation between these terminals are equal. If there is one terminal and one non-terminal, then terminal less than leading of non-terminal. If relation like non-terminal terminal, then trailing of non-terminal greater than terminal. Dollar is always less than leading of starting symbol, and trailing of starting symbol is always greater than dollar. So for E gives E plus E, E gives E star E, and E gives ID. In this grammar, we have three input operator plus star and ID. For end of string, there is one dollar sign. So there is total 4 operators plus star, ID and dollar. Note that there is no any relation between ID and ID and dollar and dollar. No any relation between ID and ID and dollar and dollar. So now check for precedence like f of x and g of x. So f of plus and g of plus. You have any function, and in that function there are many plus sign, addition operators. Then what is the relation between this plus? So your first plus is always greater than second plus. Like you have any equation like a plus b plus c. So in this equation, a plus b is always first executed. After that, answer of a plus b is added with c. So plus and plus. First plus is always greater. Sometimes greater than, less than or equal to sign, you may put dot into this relation. So this plus is greater than this plus because your both plus have same priority. In your equation, any relation, it scans from left to right. So first left addition is always first performed. So this plus has higher priority. Then plus and star. At that time star has higher priority. So priority of plus is less than and priority of star is higher. For example, if you have a plus b into c, then first b into c, multiplication is first executed compared to addition. So first execute b into c, then after result of b into c is added with c. So multiplication priority is higher. Any identifier has maximum priority. So with any operator, ID is always greater. Any dollar sign has always lower priority. So any operator has a higher priority. So plus and dollar, it's a higher priority of plus. Now star and plus, priority of star is higher. Star star. So first star is higher. Star ID, ID is higher. Star dollar, star is higher. ID plus, identifier is higher. ID star, ID higher. ID has no any relationship. ID dollar, ID priority is higher. Dollar plus, priority of plus is higher. Dollar star, star higher. Dollar ID, ID higher. Dollar has no priority. This is your operator precedence relationship table. Now construct the graph of operator precedence function. Then how you can draw the graph of operator precedence function? Here F plus, relation of F plus with other functions. So in your F plus, greater precedence will be outer word. So F plus to G plus is a greater sign. So F plus to G plus, draw arrow and it's a outer side. F plus to G star. G star is a highest precedence. So G star to F plus. Draw arrow like this. Outer precedence has a greater precedence as a outer word. Next F plus to ID. F plus to GID. So GID F plus. F plus to dollar. F plus to G dollar. So F plus to G dollar. Next F star to G plus. F star to G plus. F star to G star. Next F star to GID. GID as a greater precedent, so it's a outer word. F star to G dollar. F star to G dollar. F ID to G plus. F ID to G plus. G plus is a higher precedence. F ID to G star. F ID to G ID, no relation. F ID to G dollar. F ID is a highest precedence, so it's a outer word. Next, F dollar to G plus. F dollar to G plus. G plus is the highest precedence. Next, F dollar to G star. Next, F dollar to GID. GID is highest precedence. F dollar, G dollar, there is no any relation. So this is your graph of operator precedence function. Now, operator precedence table. How you can fill this operator precedence function table? F of x and g of x, there is input symbol plus, star, id and dollar. So first put f of plus. So here f of plus, f plus, f plus, check relationship table outer precedence. So in f of plus there is two outer precedence. First is G plus and second is G dollar. There is two outer precedence. One is G plus and another is G dollar. So from G plus to F dollar. G plus to F dollar. So this is at level 0, this is at level 1 and this is at level 2. So F plus operator precedence table, its value is 2. For F star, F star, there is a outer precedence G plus, G star and G dollar. G plus, G star and G dollar. G plus, G star and G dollar. From G plus we can reach at F dollar. From any operator precedence function you can reach to F dollar or G dollar, which is maximum at depth. Then after G star, from G star outer precedence is F plus. There is no any other. So G star to F plus. F plus 2, here you can find F plus 2, G plus, G dollar and G plus 2, F dollar. So this is at level 0, 1, 2, 3 and 4. So F star is 4. So thus you can find all the precedence table values. So this is your operator precedence table. Next is another example of operator precedence. Grammar. E gives E plus T or T, T gives T star F or F and F gives ID. So here I can find leading and trailing of non-terminal. Here three different non-terminal E, T and F. So first find leading of E. Leading of E, first non-terminal is plus. So put plus, and another product is non-terminal. So again repeat this procedure. So plus, comma, leading of T. For T, first terminal is star, then other product of T is F. So plus as it is, then leading of T is star, comma, leading of F. Leading of F, first terminal ID. So leading of E is plus, star and ID. Thus you can find leading of T and F. So leading of T is star and ID. Leading F is ID. Trailing of E. Trailing of E, it means last terminal which is plus. Then after trailing of T. So plus, comma, trailing of T. So trailing of T, star and trailing of F. Trailing of F is ID. So trailing of E is equal to plus, star and ID. Now you can put operator precedence, relationship table, graph of operator precedence function and operator precedence table. So you can draw by yourself operator precedence relationship table, operator precedence function graph and operator precedence table. Sometimes asked like pass the string, input string using operator precedence grammar. Then first you have to pass the table. First you have to draw the operator precedence relationship table. Then after you have to write down your input string. At starting and ending put $sign. Then put relationship values from relationship table. So input string to reach at starting symbol. If you reach at starting symbol, then your string will be passed using operator precedence grammar. Next is LR parsing. LR parsing is most efficient method of bottom-up parsing which can be used to parse large class of context-free grammar. The technique is called LR into bracket K parsing, in which the L is for left to right scanning of input symbol, the R for constructing rightmost derivation in reverse, and the K for number of input symbols of look ahead that are used in marking parsing decision. So mainly three types of LR parsing: simple LR, which is known as SLR, canonical LR, which is known as CLR, and LALR, which is known as look ahead LR. SLR is also known as LR0. CLR is also known as LR1. According to these three parsing techniques, CLR is the most powerful. Second is LALR and third is SLR. Any LR parsers can be constructed to recognize virtually all programming language constructs for which context-free grammars can be written. The LR parsing method is the most general